Okay, this is the final one. I'm going to do chapter 5 now. Sorry, I'm getting feedback again. Okay, so here we have no calculators on chapter 5. So my calculator, let's move it away. We don't need it. We do, however, need our, where's our sheet of, I know I have the, what do you call, formulas around here somewhere. Ah, here it is. Okay, so you can keep your formula sheet with you. All right, so let's start with number 1, chapter 5. Simplify. Cosecant x minus cotangent x times secant x plus 1. Okay, don't fall down that hole thinking that this is the Pythagorean identity. These are squared, this one is not. Okay, I can change everything in terms of sine and cosine, but I wouldn't do that yet. Okay, and remember when I taught you this, I told you for every rule I tell you, there's an exception. So I would FOIL this first and then change it. So if I FOIL this, because I'm multiplying two binomials, I'm going to get cosecant x secant x plus cosecant x outer minus cotan x secant x minus cotan x. Okay. When now that I have it like this, I'm going to rewrite it. So this is 1 over sine times 1 over cosine plus 1 over sine minus cosine over sine times 1 over cosine minus cosine over sine. Okay, this becomes 1 over sine x cosine x plus 1 over sine x minus cosine cancels out 1 over sine x minus cosine x over sine x. 1 over sine minus 1 over sine cancels out. In order to combine these, I need like terms, so I'm going to multiply this one by cosine x over cosine x. So now I'm left with 1 over sine x cosine x minus cosine times cosine is cosine squared x over sine x cosine x. Now, since they're the same denominator, I could combine them, and 1 minus cosine squared x is really sine squared x over sine x cosine x. Sine goes into one of these. I'm left with sine over cosine, or simply tan x. Okay, so that's what that would simplify to. Number 2 asks me to work on cosecant x over cotangent x. This is really 1 over sine x over cosine over sine. We've discussed this many times. When you have a fraction over fraction with the same denominator, they cancel out, because technically it's this divided by this, which is this, multiplied by the reciprocal. So I'm left with 1 over cosine x, which is secant x. Number 3, we're going to solve. Okay, and our solutions are going to include 0 but not 2 pi. All right, so cosecant squared x minus cosecant x minus 2 equals 0. In your mind, this should look like x squared minus x minus 2. I would factor that, x minus 2, x plus 1. Same thing here, only instead of x, I write cosecant. Cosecant x minus 2 times cosecant, again I spelled it wrong, sorry, x plus 1 equals 0. So that means cosecant x equals 2. which means that the sine of x equals 1/2, and sine is positive in quadrant 1 and quadrant 2. In quadrant 1, I have pi over 6, and in quadrant 2, if this is 6 over 6, this would be 5 pi over 6. And then we have cosecant x equals -1, which means the sine of x equals -1. That is one of your quadrantal angles, and it's going to be x equals -3 pi over 2. I don't know why I wrote negative. I meant 3 pi over 2. Thinking -1 because we're down here. 0, -1. There's your sign. Okay. Number 4. 2 cosine squared x minus 1 equals 3 minus 5 sine x. First, I'm going to bring everything to one side. So, actually, no. What I'm going to do is I'm going to replace this sine x with the identity over here using this one. Cosine squared x, if I bring this to the other side, is 1 minus sine x, because I see I have a sine x here. So this would be 2 times 1 minus sine squared x minus 1 equals 3 minus 5 sine x. So now I have 2 minus 2 sine squared x minus 1 equals 3 minus 5 sine x. 2 minus 1 is 1, so I have -2, and this is why I didn't bring it over before, because I'm going to bring this to the left. Plus 1 equals 3 minus 5 sine x. I hope you guys see that we start to have a quadratic, so I never want to have my leading coefficient negative, so I'll bring this to the right. So if I do, I get 2 sine squared x, right, that's plus 2, bring it here, minus 1 minus 1, I'll put minus 5 sine x plus 2 equals 0. Again, I'm going to write this without the word sine, so it's technically 2x squared minus 5x plus 2. I'm going to use my trick. X squared minus 5x plus 4, x minus 4, x minus 1, bring it back in, x minus 2, 2x minus 1. So it's sine x minus 2 and 2 sine x minus 1 equals 0. Yes, okay. So I get sine x equals 2, which I'm on a unit circle, so we'll disregard that. And I'll have sine x equals 1/2. X is going to be pi over 3, like pi over 6, like the previous one, and 5 pi over 6. Okay, number 5. Guys, you've seen this question so many times. 2 sine x cosine x equals sine x. Guys, please, you don't divide both sides by sine x. If you learned anything from me this year, please don't do that. You don't just divide things away. We'll bring this to this side. 2 sine x cosine x minus sine x equals 0. I could factor out a sine x and be left with 2 cosine x minus 1. Now I have two factors. Sine x equals 0 and cosine x equals 1/2. Okay, so who gives me a sine of 0? Again, go back to your quadrantal. Sine is y, this is 0. This is 1, 0, and this is -1, 0. So sine happens at 0 and at pi. And who has a cosine of 1/2, that would be pi over 3, and in quadrant 4, where cosine is also positive here, it would be 5 pi over 3, because this is 3 over 3, this is 6 over 3. If you're just shy of 6 over 3, you're 5 over 3. Number 6, tan squared x equals 1 minus secant x. Again, I will replace the tan squared x using this identity by bringing the 1 over. So this is going to really be secant squared x minus 1 equals 1 minus secant x minus 1 plus secant x. So I'm left with secant squared x plus secant x minus 2 equals 0. Again, it's x squared plus x minus 2. So that's going to be x plus 2, x minus 1. So secant x plus 2, secant x minus 1. So I'm going to get the secant of x equal -2, which means the cosine of x is -1/2. So x is going to be pi over, I'm sorry, the paper got stuck to me. Well, actually, it's negative, so I have to remember that in quadrant 1, it's pi over 3, but I need it negative, so I need it here and here. So this is 3 over 3, so it's 2 pi over 3 and 4 pi over 3. And secant x equals 1, meaning cosine of x equals 1. And if we go back here, the cosine of x is 1 at 0, right there. Okay. Number 7, we want to verify the identity. Guys, you should remember that we did this review before we took the Chapter 5 test. This is what we looked. So you definitely have all these answers worked out because I did do them with you. I'm just doing it again so you have it. All right. Nothing is squared, so please don't think any of these are identities. This I definitely am going to start changing things around. Secant is 1 over cosine. Oh, you know what? Do I want to multiply it by the conjugate pair? I'll start this way. 1 over cosine plus 1 over sine over 1 plus sine over cosine. If I change this to cosine over cosine, I could combine it. So that means my new denominator would be cosine x plus sine x over cosine x. Here, I would multiply this by sine over sine, and this by cosine over cosine. And my new numerator would be sine x plus cosine x over sine x cosine x. Okay, I just did, regular fractions there. All right, let's see. If I take this and I divide it by this, it's the same thing as multiplying by the reciprocal. So I really will have sine x plus cosine x over sine x cosine x times, flip this up, I'd have cosine x over cosine x plus sine x, which is the same as this because addition, 2 plus 3 is the same as 3 plus 2, so it cancels. And this cosine cancels with this cosine. Remember, you only cancel things out, guys, when you're multiplying, not when you're adding or subtracting. So I'm left with 1 over sine x or cosecant x. So that would be, what number was that? Number 7. Okay. Number 8, sine x over cotangent x equals secant x minus cosine x. Okay, let's work on this one. It's sine x over cosine over sine, which when I flip this and bring this up, I'm left with sine squared x over cosine. Let's see if I split this, okay? If I split it, I'm left with, well, you know what? I'm going to rewrite this because I see that there's a subtraction. I'm going to rewrite this as 1 minus cosine squared x and put each one over the denominator. This would simplify down to secant, which is what I wanted. And this would go into this, and I'm left with cosine. There you go. That wasn't that bad. Okay. And now let's look at 9. So I have 1 plus cosine x over sine x plus cosine x sine x. And I want that to be cosecant x. Well, I could totally factor the denominator. I could take out a sine x, and then I'm left with 1 plus cosine. Oh, could it really be that easy? And this would cancel with this, and I'm left with 1 over sine. Yes, it is that easy, which is cosecant. Oh, that one was easier. Okay, I didn't do half angle, so we're not going to do that. The sum and difference to find the exact value of the sine of 165. So I can make 165 by taking 120 and adding it to 45. Right? Whenever you end in 5, you're definitely going to need a 5. So let's do that formula. It's the sine of 120 times the cosine of 45 plus, because this is plus, the cosine of 120, the sine of 45. Okay, and you're given these formulas. So the sine of 120, guys, where's 120? 120 is here. This is 120 degrees, which means the reference angle is 60. So the sine of 120 is the same as the sine of 60, which is radical 3 over 2. Okay, you're in second quadrant, it's positive. The cosine of 45 is radical 2 over 2, plus the cosine of 120 is 1/2. But 120 is negative here, and radical 2 over 2. So this is radical 6 over 4 minus radical 2 over 4. Okay, which question was that? That was number 11. And you could put it together as radical 6 minus radical 2 all over 4. 12. I don't know, you guys keep getting this wrong. I can't explain it. It's very easy. They've expanded it. You bring it back. It's a tangent formula. How do we know it's a tangent formula? It says tangent. It's a subtraction formula. How do we know it's subtraction? It says minus. So this is really the tangent of 160 minus 40, which is the tangent of 120. Just tell me what the tangent of 120 is. Go back here. The reference angle is 60. You're in quadrant 2. Your answer will be negative because you're in quadrant 2. Tangent is negative in quadrant 2. The tangent of 120 is the same as the tangent of 60, which is radical 3. That is your answer. That's all you have to do there. You have to subtract and know the unit circle. Okay, double angles. All right, they're telling me the sine of theta is 1 over 6. And we're an interval between pi over 2 and pi. So we're here. This is where my triangle is. Sine is opposite over hypotenuse. So we need to find this because we need to find the cosine. So this is 36 minus 1. I'm doing square roots, doing the Pythagorean theorem. This is radical 35. So the cosine is radical 35 over 6. There's the hard part. That's the only part that's hard because sine of the double angle is just 2 times the sine of that angle times the cosine of that angle. 2 times the sine is 1/6. The cosine is radical 35 over 6. Just do math here. So I'm left with radical 35 over 18. Okay, now I'm sorry, but I forgot to tell you the cosine here was negative, so this is a negative answer. Sorry about that. Now we do a cosine formula. Cosine formula, you have 3 to choose from. Pick whichever one you want to do. 1, 2, 3. Since we have sine and cosine, may as well do that one. Cosine double angle is cosine squared minus sine squared. This is your cosine. If I square that, I'm left with 35 over 36, right? Square root, you're left with that. Square 6, you get 36. Minus, squaring 1 over 6 is 1 over 36. So you're left here with 34 over 36, which can be reduced by 2 to 17 over 18. Since I squared it, there is no negative. Tangent, I told you many times, don't use the tangent formula. Tangent formula, yes, they give you. You can use it. It is there. Where am I? This formula, or tangent is sine over cosine. Come on, guys. Put negative radical 35 over 18 over 17 over 18. And again, denominators will cancel out. Negative 35 over 17. I can't make it any easier than that. Okay, and the last one. So you're given the sine of x is 4 over 5. You're given the cosine of y. Notice x and y, two different, is 8 over 17. And we want you to do cosine of x plus y. So that formula is cosine x cosine y minus, because it's a cosine and you're given this, so I don't expect you to remember it, sine x sine y. What is the cosine of x? I have no clue because they gave me the sine of x, so I have to find it. And it says that they're both positive acute angles, so we're in quadrant 1. Everything's positive. If your sine is 4 over 5, guys, at this point, come on, you can't figure out what it's going to be? Sine, here's x. Sine is opposite over hypotenuse. What's this number? 3. The cosine of x is 3 over 5. 3 over 5 for cosine. Cosine of y is given, 8 over 17. Minus sine of x is given, 4 over 5. Oh, you don't have the sine of y. Same deal, guys. Okay, if the cosine is 8 over 17, this one is 9. This is 9 over 17. So we're left with, let's see, 35, 85 is in the denominator. This is 24 in the numerator, minus this is 36. So it's going to be, wait, is this 9? Why am I thinking it's not 9? 17 times 17, 9, 4, 7, 8, 9, 10, 11, 1, 7, 9, 8. Is that right? That doesn't seem right to me. 49, I guess so. 189 minus 64 is 5. I'm having like a really bad Wait, this is 8, so it's 64. 5 to 125. That does not make sense to me. Okay. 17 times 7 is 49, 7, 8, 8, 9, 10, 11, right? 7, 1, 9, 8. Oh, because this is 2. Hello, I'm like flipping out. And so that isn't, it's 15. I knew the 9 wasn't right. I'm sorry, guys. 225, 5, 2. Yes, okay, there we go. I had a moment. So now 4 times 15 is 20. Put 2, 4 is 60. And then this is negative 36. Okay. On the last question. All right, guys, I hope these videos helped you. I hope you review. This test is definitely passable.